In this video tutorial, we're going to take a look at how we can write a simple Raymarcher in Unreal 5 using HLSL in custom nodes. Now what this will allow us to do is to draw 3D shapes or signed distance fields or functions based on our current camera angle. So as an example, I have this material here that's a Raymarched sphere, and if I place that on all three of these objects, it doesn't really matter what the object shape is, it will draw a sphere once that object has that material. And I can rotate around these objects now, and it's the same as having almost like a geometry sphere in the scene. It's fully 3D. Yet if we look at the wireframe, it still shows as original shapes. This sphere or this new shape is not drawn with polygons or edges or vertices. It's simply drawn with pixels based relative on our camera angle to that surface or to that point in 3D space. So it's a pretty neat thing that we're able to do, and we can start doing a lot more complex stuff with this. But first of all, we're going to take a look at what SDFs are, what signed distance fields or functions are, and again, they're really just a math equation that describes a 3D shape, and we can draw this shape based on the camera angle using a method called Raymarching. So let's take a look at how we can create our very first Raymarcher in Unreal. So to begin creating a Raymarcher in Unreal, we're first going to look at what we're going to draw with the Raymarcher. So we want to draw a 3D sphere in this case. And I'm just going to open up Visual Studio Code so we can take a look at the different code that we do to draw a 2D circle and a 3D sphere. And it is very simple. So like a 2D circle, we would end up just doing something like length and then position minus UV. That will give us a essentially just plotted 2D circle with a gradient. So you'd have your center point, and it would fall off from that center point as a gradient outwards and draw ourselves a circle and a fall off. And if we want to specify a size, we could do other things like, if it's less than a certain size, then it will just ignore those pixels or draw them. And there's things we can do to start, changing how that circle's sharpness of the edges are and stuff like that. But that's essentially how we draw a 2D circle. Now, how would we do a signed distance field or a signed distance function to draw a 3D sphere? It's really not that much different. To do a 3D sphere, it would really be the same thing. We'd do length, but instead of position, we'd do something called rayOrigin, which is the starting point of the ray in 3D space. And the rayOrigin is pretty much going to be our camera vector minus the world position. And that's going to give us the starting point of the ray to draw this signed distance function or field correctly. So we'll go into that a bit more, but essentially position gets replaced with rayOrigin, the position of the starting point of the ray in 3D space. And instead of UV, we just minus sphere center. So in the UV case, it's the UV coordinates, whereas here we minus the sphere center, where in 3D space is that sphere being drawn. So that's going to be essentially the same. It's not much different. And then finally for the sphere radius, we'll just do minus sphere radius. So it's a little bit different, but overall pretty much the same. And we're going to go over how you can draw more things with signed distance fields and functions, different shapes. But for now, we're just going to start off with the sphere. And now that we know the function or the signed distance field or function to draw a sphere, we're going to draw it by using Raymarching. So that's going to be the next step. But really, it's not that much different. So same idea. It's just starting to get a little bit more complicated since we're moving from 2D space into 3D space, and it's all going to be just plotted points relative to the camera by using Raymarching, but it's really not that much different. And hopefully after the next few steps, you'll see that it doesn't have to be that complicated. So the next thing we're going to do is actually start writing our Raymarcher now that we know how to create a 3D sphere using a signed distance function or field. So to begin creating our Raymarcher, we have to really just start with defining that ray origin. Where does the origin of the ray start? And to do that, we're going to define a float3, and it's going to be rayOrigin, and we'll make it equal our view direction, which will end up having a variable in Unreal called viewDirection that connects to our camera vector, and we're going to minus the world position or absolute world position in Unreal from that camera vector, and that's going to give us our rayOrigin. The next thing we're going to do is define a rayStep variable, and this will be viewDirection again, so our camera vector just multiplied by 1, which is just good practice to make sure we typecast it into a unit. And then we're going to do a for loop. So our for loop is going to be what steps through all these kind of positions and draws our actual shape. So you have to define a number of, I guess you could call it samples or loops. So it could be like 128, or in this case, we'll do 256. If you do too low of a number, your shape won't draw fully. It'll look kind of wrong, or kind of maybe clip away or disappear, or feel like it's tons of little slices, or it won't look as good. So you want to have enough steps here for when you draw your Raymarched object. Otherwise, it won't look good, or it'll start flickering or disappear. So I think 256 is maybe a little bit overkill, but we'll go with that. So we're going to do a loop 256 times. And what we're going to do inside that loop is define our signed distance field or function of our shape. So I'm going to do float distance. That's our distance field or function. And it's going to be length, exactly what we talked about, length rayOrigin minus the sphere center. So we'll have to make another variable called sphere center. And then we'll minus sphere radius, how big we want that sphere to be. And then what we're going to do is we're going to do an if statement that will check whether we're inside that sphere's shape or outside of that sphere's shape. So we're going to do if distance is less than 0.01. If that's true, we're within the circle or the sphere that we defined with our signed distance function. And if that's the case, what we're going to do is return the color red. So we'll return the pixel as red. Now, if we're not within that, otherwise everything else will just add like a step to the ray. So we'll do rayOrigin after this. Even if it was within that distance, at the very end here, we're going to add a step to the rayOrigin. So we'll do rayOrigin plus equals step. So plus equals adds on this value to whatever value rayOrigin is. So let's just think about this for a second. rayOrigin is our starting point of the ray, essentially. And what we're doing is we're doing a loop 256 times. We're checking whether we're within the distance of that sphere that we're defined by our signed distance field or signed distance function here. And if we're within that sphere, the distance is close enough and we're within it, we draw the pixel as red. And then we add a step to our rayOrigin. So our rayOrigin increases and it does it again. So it steps through pretty much the whole object, or it steps through this many times when it Raymarches that shape, and it checks each time whether we're in that shape or not. If we are, it draws the pixel as red. Otherwise, we'll draw the pixel as black or like empty. So we'll do return float 3, 0, 0, 0 for red, green, and blue if we're outside the signed distance field or function. So you could technically look at it like this way. Everything gets drawn as black or empty. But if we're within the distance or within the position in 3D space of our signed distance field or function, then we draw the pixel red. And it loops through 256 times, each time adding our rayStep onto our rayOrigin. And our rayStep is just the camera vector times 1. So it's stepping through this many times. And of course, the more steps you have, the more accurate the shape will look, the less flickery it will be. Too few steps, it won't be able to draw it in enough detail, or it'll have kind of little glitches where it disappears from certain angles or doesn't draw properly. So this is our code. This is Raymarching. This is Raymarching our sign distance field. Quite easy. It's nothing crazy. 16 lines of code. And if we take all this and we put this into Unreal, so I'm just going to go here, create a new material. I'll call it Raymarcher. Create a custom node. Maybe we'll change a custom node and just call it Raymarcher. That's it. We'll connect it up to our missive for now. And I'll paste in the code. There it is. We'll add our inputs and outputs because it's going to give us a bunch of errors. It doesn't know what view direction is or world position. So we need to add all those inputs. So let's start off. We're going to add our world position. We're going to add, what else do we need? View direction. We're going to add our sphere center. And we're going to add our sphere radius. And those are all the variables that we referred to that we haven't defined. So there we go. Now we need to connect these up. So world position goes to absolute world position. There we go, world position. World position node is absolute world position. View direction will just be camera vector, world space. And then sphere center, we'll just put it at 0, 0, 0. So constant 3 vector. And sphere radius, we'll just put a single value into it. And it will be maybe something like 50. And there we go. We have our red pixels drawn. And whether the object is a sphere, whether it's a cube, whether it's a cylinder, it's drawing that object correctly on that surface regardless. Now we get some shading on this object. We don't want that right now. So we're going to go to our material here and set it to be the shading model of unlit. So it has no lighting affecting it. And now we end up with this. And that already is working. We are successfully Raymarching and drawing our signed distance fielder function in 3D space because we're doing it relative based on the camera angle. So it feels like we can almost rotate around this sphere and everything's working correctly. So pretty awesome. But we have this big problem where we still see the shape. If I apply this material to a cube, I still see the cube as being black or dark because it's drawing those pixels as dark. Just like when we looked at in the code, if it's not red, if we're not within the bounds of that sphere, we're returning a black pixel here. So what we maybe want now is a way of cutting away those areas that we don't see. So how can we fix that? We can do that by outputting another variable for opacity, just like we looked at in the last video. So that's something we'll have to do. But before doing that, there's one big problem with this right now, and you won't see this issue until you apply this material to an object in your scene. So if I go back into Unreal here and I just create something like a cube, there we go, and I apply this material, hey, where's the sphere? Now if I reset this cube to 0 position in world space in XYZ, there's our sphere. But if I start to move this cube, it cuts off our sphere. So the problem is our sphere is drawn in world space. And let me show you an example of this. If I scale this up and I go inside our code here, and for our sphere center, I draw it maybe 1 on the z-axis. Actually, we don't even need to look there. We can just look here. If I look at that sphere, maybe 2 on z-axis. 5, 10. Is it moving? Let's see. Try 100. There we go. It moved. Moved down. So this is controlling its position in world space, but that's a problem because we don't want to have to define our object in world space. Then if we want to move this, it cuts off our object and we have to calculate wherever that new position is. That's too much work. It should always stay in the center of whatever object we assign it to. So how can we make that modification? How can we make it so that this shape or our signed distance field automatically moves to wherever our object is translated or placed? And this is really easy to do. Instead of making our world position just equal our world position, we're going to do our world position subtract our object position. And by doing that and using that as our world position now, nothing changes here. Everything looks the same. But when I save that now, by taking our world position and subtracting our object position, now it won't matter. I can move this object wherever I want, and that circle or that signed distance field or function that we're drawing stays within this object. So that's kind of something we're going to want to modify. So that was really easy to do. And now what we want to do is clip away that dark area. So what we're going to do instead is add an output to our Raymarcher. So we'll go down here, add an additional output. That output is going to be called opacity mask. We're going to change our material type to be not opaque, but to be masked. So we get the opacity mask connection here. We can connect it up, but it's not going to be able to output anything, so it just disappears. So we have to modify our code. We're going to modify our code here to be a little bit different, where we're going to use that opacity mask variable, and we're going to say opacity mask equals 1. So solid if we're within the SDF. And we can actually just put this here, and that should be fine. And technically, this would all work. And then if we're not within that distance, we can just do opacity mask here equals 0. And this should work. And actually, technically, we could put this inside our distance function here, but it should still work here. Shouldn't really matter. So let's give this a try. I'll copy this, throw this into Unreal, update our code. Does it work? Hey, there we go. Now we get our sphere nicely clipped out in 3D space. So now if we look at our object, there it is, a sphere that we can fully rotate around. Now, I know this doesn't look great. It's just a simple sphere that we have. We can change the size. We can make it bigger or smaller, modifying the sphere radius. A lot of this stuff is adjustable, but it's very simple. We're just drawing a sphere. So what would really help this look better, what would really take this to the next level would be to add some shading on it. It would be nice to get some shadowing on it, some highlights on it. So that's going to be the next thing that we're going to take a look at. How can we write in our HLSL code a way of calculating a light position or light direction and using that to do some shading or shadowing on this, this Raymarched sphere. And again, this isn't geometry. It's really just points being plotted, or not even points, that's a bad term, pixels being plotted based on our camera position. So it's really just pixels being calculated whenever the camera moves to draw this shape. If I look at the wireframe, there's no actual geometry there, it's just a cube, but it's drawing this sphere based on the math from the camera angle and using Raymarching to pretty much step through all the positioning of that shape and draw these pixels. So that's kind of the easiest way I could really explain it, but now we're able to draw our signed distance field, and the next thing we're going to take a look at is adding some shading to this. So if you learned something new in this video and you found it useful, please like, please subscribe, press the bell notification button to be notified about new videos. And if you are part of the Patreon, which has a link down below in the description, you'll also receive the access to get this PDF that goes over what we kind of talked about in this video in a little bit more detail, and just works as a good reference point for if you're having to do this and you forget some of the steps and you don't want to rewatch the video again. So if you're part of the Patreon, go check that out and download it. and I'll see everyone again in the next video.